more and more current through it until it gets brighter and brighter until the magic smoke goes out and the part goes out. Usually we don't want to do that, like I said. So that's why we usually have resistors to slow down the electrons to have less current so the part doesn't burn out. But the amount of current that can come out of the output pin of a microcontroller is not so much. We can turn off TVs, but not far away because there's not a whole lot of current. That's why we use transistors. Transistors, with a little bit of current on its input, allows a huge amount of current on its output. So if we hook the input of the transistor to the output pin, and the output of the transistor to the LED, then the LED's going on and off and on and off, really bright, so it'll turn off TVs from far away, making the world a better place from more places. And if we have 4 infrared LEDs, then it's 4 times brighter. Each one gets its own transistor. But it turns out that the amount of current that a output pin can give is not quite enough to even drive 4 transistors hooked to LEDs. So we hook this transistor, which is different. Remember, this is different than these. This one goes to the output pin of the transistor, and the output of this goes to the 4 input pins of the transistor, and the output of these go to its own LED. Okay, so that's most of electronics. There's one other part. Capacitors. So capacitors are little buckets for electrons. So the thing is, in electronics, there's often times, like right now, where we don't need a whole lot of energy, but a little bit later, we need more energy. So capacitors are little buckets for electrons so that we can pour a few electrons in here when we aren't using much energy, and then pour them out a little later when we can use that energy. And when we're pulsing these on and off and on and off to make off codes, when they're off, we don't need a whole lot of energy. So we can store some in these capacitors. And then when they pulse on, we need more energy, so we can draw the electrons that we're stored in here to make them go just a little bit more brightness. These are measured in farads, named after Michael Faraday, he's another named physicist. Okay? So that's pretty much electronics. Oh, a switch. A switch is just 2 contacts. This one has a spring in it, so that when you push on the switch, it connects 2 pieces of metal together. When you let go, the spring makes it go boom. And when it's down, of course, electrons can flow. When it's up, they can't. That's really all there is to all this. And you know, I don't expect you to have memorized everything I just said, but hopefully what I said gives you a feel for how this stuff works and why we use the parts we use. Okay?
So this is
yeah, so that's hooked up to an input pin, a pin that we program to say this is an input, and then we have part of the program is to say, look at that pin, is it high or low? If it's low, actually, when you push the button, it makes the pin low. So when it's low, start transmitting off codes. And keep doing that until you transmit all of them and then go to sleep. And then when it's asleep, keep looking at that pin to see if I should wake up and then start transmitting. That is not. That's the red green pin. It's the same as in TV. You can't tell that it's infrared by looking at it without being because there are LEDs that look exactly like this, can be orange or amber or red or blue or whatever. So you just have to know.
The way we're explaining that when you're waving your hand is that it's like bouncing that light off the receiver.
Yeah, and that's